anytime we go through a review, we like to start with size up. We just like to hit on that just briefly as far as the importance of it, especially when we get into our commercial buildings. Those big buildings, they can hide a lot of stuff that we can't see, and then also a lot of times they will present differently than what's actually going on. So size up is important. We would like for you to maybe just slow down a little bit. You know, on residential, we pull up, get a real quick view of things, go to the roof, do our operation. On commercial, we would like not only the captain, but the entire crew to spend just a little bit of time collecting those fire ground factors that are pertinent, trying to figure out what's going on a little bit before you jump on there. The thing about size up is that it's not something that automatically comes. You have to make a conscious decision to do it. It's not something that we automatically do. So you have to make yourself do it. When we get on the fire ground, there are a lot of distractions going on. We have engines laying lines, we have people, you know, citizens out there doing all kinds of things, moving cars, getting out of buildings, doing a lot of things. And then our own crew trying to communicate with us. So a lot of distractions. So everybody's going to have to just keep their head up, try to collect, like I say, those pertinent fire ground factors and get a good size up. As far as whether the building's ventable or not, we would like the ladder crews to make that decision. In order to do that, you need to put yourself in a position to where you can make that decision. It's hard to, a lot of times it's hard to do from the ground, so you need to get yourself into, most of the time on the roof, determine whether that's ventable or not. But the other part of that is you have to give good feedback to command. They need to know what's going on. So what you see a lot of the times isn't what's actually going on in the building. So like I say, you got to put yourself in a position, probably going to be on the roof, give a report to command whether that building can be vented or not. Travel on the roof. Just remember when we're walking on these roofs, whether it's commercial or residential, the golden rule on a roof is don't walk there unless it's been probed. We have to live by that rule. We absolutely have to follow that rule. So we don't care who that probe person is. Probably not a good idea to make the least experienced person on the crew the probe person, but it doesn't have to be the captain. So you guys can designate whoever you want to be your probe person. What tool they use doesn't make any difference to us. You guys use the tool that you feel most comfortable with and you feel gives you the best read for what you're doing there. We do recommend, however, that if the captain is not the lead probe person, that he is the second person behind that probe person. The captain should have some input as to where that hole is going to be located, and if he's not right behind the probe person, it's going to be hard for him to get that person's attention and redirect him. So captain should be, like I say, in close proximity to the probe person. We do a pretty good job walking, doing our travel on the roof, probe person leading, and getting us up there. We do want to make sure, like I say, that we're following that golden rule and that we're not walking anywhere on that roof unless it's been probed. As far as our roof operations go, what we want to do is we want to establish a standard Phoenix Fire Department roof operation. That consists of 3 people. We don't have any 2-person roof operations. We want to have consistency across the board, so that no matter who it is, whether it's battalion chief sitting in a pickup half a block away, whether it's an off-duty fire department personnel watching the 5 o'clock news and watching live footage of a firefight, everybody should have be comfortable with what they see. Nobody should have any heartache over what we're doing on a roof. They should be able to look at it and say, yes, that's a standard Phoenix Fire Department roof operation. In order to achieve our standard Phoenix Fire Department roof operation, we have 3 roles that need to be filled every single time we go to the roof. So real briefly, the first role is going to be the operations oversight person. Most of the time that's going to be the captain that fills that. The role of that individual is to have a broad focus the whole entire time. At no point in time will his focus be narrowed down to the task level where he's doing something with a tool. The whole time, like I say, his focus is going to be wide. He's going to be watching the building. He's going to be watching the fire conditions, smoke conditions, and then he's going to be watching his crew. He's going to be standing back a little bit but we feel comfortable that at the same time that person can have a pike pole in their hand. So while the other two crew members are doing the cut operation, this person can have a pike pole in his hand, and he can either be doing a semicircle or a full circle around those two members, checking the decking material, watching the building, watching the fire conditions. Like I say, keeping a heads up, full focus on the whole event, no point in time narrow focus. The cut person is going to be responsible for making sure he's familiar with the flooded saw procedure. We've seen it over and over again when there's high adrenaline in these guys. They start pulling on the saw, they get it flooded real quick, which those, especially the chainsaws, do fairly easily. So he's got to be familiar with the procedure to get the saw started once it's flooded. The other thing the cut person has to be familiar with is that he's got to be good with a sequence of cuts. So once he starts the saw, they identify where the cut's going to be located. He's got to know immediately exactly what a sequence is going to be. Everybody on the roof should understand what he's going to do next. It's really hard to talk about it at that point in time. The saw is running, face pieces are on, so it should already be scripted, and he should be familiar with it. The backup person is extremely important. What we do is we put our cut person in a real vulnerable spot because we have him narrow his focus down to an area about this big. He's bent over looking down at the ground, and we have him walking backwards while he's doing this. And then a good part of the time he's either going to be in limited visibility or no visibility because of the smoke. So what we want to do is we want to have a strong backup person there for him. We want the backup person to have two hands on the cut person. The backup person doesn't need to have a tool in his hand. We have the operations oversight person over there checking the decking material, monitoring the whole area over there. So the backup person can focus on helping out the cut person. A lot of times our least experienced person on the roof is going to be the cut person. So we want to have a more experienced person there helping him back up. We want to make sure the cut person doesn't back off the roof. We want to make sure he doesn't back into any obstacles on the roof. Also, the backup person is going to help the cut person if the cut person's cuts are too deep, if they're not deep enough, if they're too long, if they're not long enough, whatever's going on, if the sequence isn't good, the backup person can stop the cut person. They can communicate whatever the problem is, and then they can go back to the cut operation. But at no point in time should the backup person let the cut person do an unsafe operation or get into any trouble. So he's there to give that cut person the confidence he needs so he can narrow his focus down to that real small area and go ahead and do the cut operation. So what we end up with is we end up with a cut person having a focus in an area about this big right here, which is exactly where we want him to have his focus. He should be watching that bar or blade on his saw, and then stepping back a little bit, we have the backup person who has a focus on an area about this big right here, just the general area right there. And then watching over the whole big operation, we have the operations oversight person who is watching that operation. He's monitoring the building, he's monitoring the fire conditions, and he's monitoring the decking material by probing. Just a couple other things to wrap up the roof operations review. One is that in the Phoenix Fire Department, we've pretty much standardized the 4x8 louver cut on our wood decked roofs. So whether it's commercial, residential, pitched, or flat, a 4x8 louver is our standard cut. That's what we do. That's what the crews are using. It's fast, it's effective, and it's safe. Another thing that I want everybody to be aware of is that once we cut a hole in a roof, we don't make that hole any bigger. We're operating around that hole anymore. We make our cut, we louver the louvers, we punch the ceiling, and then we get away from there. The reason is because we potentially have weakened the structure, and then the other thing is that now there should be some smoke coming out of that hole. And so if you need more ventilation, move away from the hole you cut, go to another area and cut another hole. And if there isn't any smoke coming out of it, you don't need another hole. And so if there is smoke coming out of it, at some point in time, visibility is going to be a problem. So get away from that, especially when we get into our commercial buildings. You're 25, 30, 40 feet in the air. Anything that that can go wrong. If anything does go wrong, it's pretty unforgiving. It's not like you're going to walk away from that. So just make sure once you make a cut, if you need more, get away from it, make another cut. On this particular building, we took our pick head axe, we dug up some of the top material here. We identified that we have a metal decked roof. When we get into metal deck roofing, the first thing we want to look for is we want to look for the channels. We want to see the channels on the decking. We want to know which way they're running. In this particular building, our channels are running this way right here. So that's going to lead in to the reed of the roof. So once we know which way our channels are running, that's going to tell us which way our purlins are running. And that's what we want to identify. When we talk about the reed on a roof, we want to identify our purlins. What we have on top of on your metal decking, there's going to be some sort of rigid board. The most common material is it's a foam type rigid board, and it's anywhere from 1 inch up to 12 inches thick. The rigid board will always be attached to the metal decking. They can either glue it on, or they can use a long nail with rings on the shanks, and then a big metal washer up on top of that. And that nail will actually be driven down and through the metal decking, and that way it'll hold the rigid board on. So the board actually can be plywood, it can be a gypsum type material, it can be the foam rigid board, but the foam rigid board is the most common material to see out there. So the next thing we want to do when we identified that we have a metal decking, the next thing we want to do is we want to start looking for the location of our purlins. So we know our purlins, because our channels are running one way, we know our purlins are running the opposite way. So what we want to do is we want to start and just tearing up the material on top here, our rigid board up here on top, and start tearing up. It's going to be a small channel about 1 foot wide, and we want to run it perpendicular to the purlins. And what we're looking for is we're looking for a screw, a rivet, or a weld. They attach the metal decking from the top side, so there'll be some sort of attachment point there, and that's what we're doing. We're just tearing up the material on top here, getting it out of the way, and we're looking for when those channels cross over a purlin, there will be an attachment point. That's what we're looking for. Once we find that purlin, the location of that purlin, what we want to do is then we want to remove all the material up on top of that. So what we're going to cut is a 4x8 hole in that metal decking. So we want to cut about a 5x9 area where we remove all that material. One of the best ways to do it is just take your wood blade circular saw and just do almost what looks like a 4x8 louver. So it'd be a 9x5 louver, where you just make a big box and just chop it up fairly small pieces. You can take your axe, you can take a pike pole, you can take a scoop shovel if you can get one up here. You just remove all that material, get it off the top of that metal decking, because we're going to be cutting that metal decking, but we got to get to it. Remember, our circular metal blade saw will not cut through any of this material. All it'll do is just smoke and not cut anything. So we want to get all that stuff out of the way so we can actually get down to the metal decking. Very time consuming, very labor intensive, but it does, with a little bit of practice and a little bit of training, it's easy to do, and we can get that cleared off and get us down to that metal decking. Okay, so we have all the material cleared off. We have an area approximately 5x9. We've identified where our purlin is. The purlin's on the edge of that. The area is all off to the side of the purlin. So now we're ready to get our metal blade circular saw and start our cut. Remember, this cut we're calling a right-handed outside cut. And say this is our purlin right here. If that's our purlin, what we want to do is we want to start perpendicular to the purlin. So the cut guy's going to be cutting like this. I'm just going to draw this out, and this is what the pattern of the cut's going to look like. And we'll be, remember, we're on the metal. All this is gone, we're on the metal. So we're going to come 4 feet off of that purlin. We're going to just make a cut about 4 feet this way. And when I'm talking about this right-handed outside cut, remember, the saw is up here, the feet are back here, and so he's in a good safe area the whole time he's cutting. At no point in time is he standing in an area that's already been cut. When you get 4 feet away from that purlin, we don't know where the next purlin is. It's out here somewhere. We don't know where it is. Doesn't make any difference as long as we're not crossing another one. We're just going to put a little notch in that corner right there. It doesn't have to be very big. We're going to turn the corner. Now we're going to come this way. Remember, we're overlapping our cuts. We're cutting along. Here again, the cut guy's feet back here. He's cutting right there. Cutting like this, coming along about 8 feet. Going to turn, going to notch that corner right there. Now we're going to turn back. We're going to come 4 feet this way. Now we're back on the purlin. So we have a cut right there. Now the cut guy and the backup guy are working off the top of a purlin. They're going to come along this way right here. They're going to go about halfway. They're going to leave a tab in the metal there. We're going to call it a hinge. Lift the saw up, leave it, continue the cut, come along this way right here, overlap it. Now the cut part of this is done. Once our cut guy is done making the 4x8 cut, we take our pike pulls, we hook the corners, the notches in the corners that we made, and we just flop this out. Remember, we have our hinge there so we can pull it back, and then we just bend it back like that. The reason we put the hinge in there and peel it back is if we tried to just make it just a regular 4x8 cut and let the thing fall in, probably wouldn't. We have electrical conduit under there, we have plumbing for sprinkler systems, and then a lot of times there's just some sort of a small construction feature underneath there that'll keep that from falling out. So what would happen, it would fall in a couple inches, and basically we'd have an obstructed hole there. So this way what it does is it gives us unobstructed hole, good 4x8 area for smoke and heat the vent out of that thing. On this right here, we talked about identifying, reading the roof, identifying the purlin. That's absolutely critical. The B decking is strong enough to where if for some reason you ended up with a purlin in the middle here somewhere, so if you made your cut and you ended up over the top of a purlin, there's absolutely no way you could bend this back. You don't have enough manpower on this roof to bend that B decking back. The only place the B decking will bend is where you've cut it. And if there's a purlin in the middle, it'll be attached to the purlin and you will not peel that back. So make sure, it's critical, make sure that you identify where your purlin is. Your cut starts on the edge of that purlin, you're working off that purlin away from it, either one way or the other. And then you come back and you end up on top of it, pull it back this way. On these commercial buildings, since there are skylights in this particular one, we probably wouldn't have need to cut a hole, but a couple of things to keep in mind on these big box commercial buildings. One is that typically there's an office space somewhere in the building. Office spaces will not have a skylight over them. So if you had a fire in the office, you would probably need to do something to relieve that heat and smoke out of there, and topside ventilation is probably your best bet. A lot of the offices are 2 stories, so if you had a fire in the 2-story one of those offices, that's about the only way you're going to get any relief in there is to cut a hole. The other thing is that your skylights most of the time are found in big box warehouses. When you get into big box retail like your Targets, your Safeways, your Fry's, most of the time they do not have skylights. So if you're having an event in one of those buildings, then you're probably about the only thing you have to rely on is going to be topside vertical ventilation. A lot of those are commercial metal deck buildings, and so that's where this technique is going to come in. Okay, we're inside of a big box warehouse, and we just want to talk about a few of the construction features inside here. As you can see, what we have our steel I-beam posts. The posts are holding up girders, they're supporting girders. And then running perpendicular to the girders, we have our purlins. In this particular case, our girder is an I-beam. This is a metal deck roof. On metal deck roofs, your girders can be an I-beam or it can be a steel truss. And then our purlins, the smaller members, structural members up there, those in this particular building are Z-channel. They can be C-channel, they can be Z-channel, or they can be a steel parallel cord truss also. Over the top of the purlins, we have running our metal decking, our commercial roof metal decking. The most common metal decking out there is 20 gauge B decking. This particular building has the 20 gauge B decking on top of it. So what we want to do is we just want to talk about a couple of differences here between commercial construction and residential construction, and we'll point a couple of things out here. One of them is that in residential construction, our structural members are good as when there's a working fire, like in a house, working fire in the attic. Our structural members will last longer than the decking material. So what we do is we use the decking material as our clue to tell us what the structure is doing. So if the decking material is good, we know that the structural members are good. We've experienced that multiple times throughout our careers. There are labs that actually have tested that, and they've verified that it doesn't make any difference whether it's conventionally framed with rafters or whether it is a newer construction with trusses. The trusses, the rafters, will last longer than the actual decking material on top. So by us probing, by us doing our sounding, we can tell what the structure is doing, and if the decking material is good, we know that the structure is good. When we get into commercial, it's a little bit different because we have things like our posts here, we have our girders, we have our purlins, which are bigger structural members in residential. And what we can have is we can have the fire affect these other structural members without actually showing anything at all in the decking material. So on this steel post, unprotected steel post right here, we have a fire load around it. Sprinklers are way up high. If for some reason we got a fire in here, we could have direct flame impingement on that post, and we know at about 1100 degrees that steel is going to start to move, bend, twist on us. So, and that could happen before the sprinklers set off. So what we could have is we could have a large structural member start to fail, start to move, before we saw anything at all in the decking material, which is completely different than what we talked about with residential. Also, what we can have is we could have some flame impingement on that girder up there, or in some buildings on a truss, or I'm sorry, on a purlin, and that could affect the structural integrity of the roof without showing up in the decking material. So when we're looking at this commercial type of construction right here on our metal deck commercial roofs, what we have is we have our posts, we have the girders, and we have the purlins. We do not have joists. So in wood commercial buildings, wood deck commercial buildings, we will have joists. That'll be the third structural member that we'll have up there on as the roof structure. In commercial metal deck roofs, we don't have the joist. On this particular building, you can see your Z-channel purlin sitting on top of the girder. But in a lot of your other metal deck commercial buildings, your purlins will actually be hanging from the girder rather than sitting on top of it. This is a little bit better of a connection, so it sits on top. When they hang from the side, there isn't as much surface-to-surface contact, so you get a less stable in the event that there's any type of movement or flame impingement on that steel. In these buildings, on these commercial metal deck buildings, the distance between the purlins, there really is no set standard. The way that works is for 20 gauge B decking, the purlins can be spaced from 3 feet to 12 feet apart, and then the span, there is no set distance on the span. So we don't have any rule of thumb to go by on that as far as the distance between purlins. When we get into our wood deck commercial buildings, we do have a rule of thumb to go by, but on metal there really is no rule of thumb. On this particular one, you have about a 5 to 6 foot span between purlins, but it can be all over the place. Now we're in a big box warehouse, and this particular building is older tilt slab, and it does have wood decking on the roof. So just to review again of the construction features in here, we have our steel unprotected posts, which are holding up girders. In this building, our girders are just a big glue lam. They can be a truss member, either metal truss or wood truss. But like I say, in this particular building, we have a glue lam there. From the girders, we see the purlins. The purlins of this particular are just dimensional lumber. And then from the purlins, we go to the joists, and as you can see there, our joists run between the purlins. Those joists are just a 2x4 on edge. And then on top of that, we have our wood decking material. So here again, in this type of building, what we can have is unlike residential, we can actually have structural failure without having anything on the roof that gives us an indication that we're going to have that. In residential, we're checking our decking material. That's our clue. On these buildings, you can see we have some pretty good sized structural members down here that could be infected by fire without the decking material being affected by fire. A couple things about these buildings. We talked about the reed on the roof, how important that is. And for these types of buildings, a rule of thumb, now there aren't any absolutes, but a good rule of thumb that we can work off of is that when we get up on the roof, in order to try to find out which direction our purlins are running, what we want to do is we want to look for the walls that have the drains on them, whether it's scuppers or drains against the walls. So once we identify where the drains are, our purlins are going to be running perpendicular to that wall. So what we want to do is start sounding across, trying to feel a purlin. Once you feel a purlin, you can double check it, move 8 feet away, double check it, see if you have another one. That way you know where your purlins are. The reed on the roof is important so that we can orient our 4x8 louver cut over the top of those joists, and it louvers right over the tops of them. Now, we talked about on metal deck commercial buildings that there really is no rule of thumb on your distance between purlins. When we get into wood deck commercial buildings, we have a rule of thumb there, and those are usually 8-foot centers. So once we find it, we're on a wood deck commercial roof, we find a purlin 8 feet away each direction, we should have our other purlin. The other thing about these buildings, these big wood deck commercial buildings, is that, which is different from residential. On residential, when we're making our 4x8 louver cut, the depth we go on those, whether it's rafters from conventional framing or trusses from a newer framing, the depth we go on those isn't all that important. We experience many times where we cut all the way through those and it doesn't affect the structure. All we have is just some load redistribution around that hole, and the structure itself is safe. When we get into these, we lose our structural redundancy. We go from 2-foot centers on our structural members in residential to 8-foot centers on our structural members. And so we lose that structural redundancy. So now when your cut guy is making that top cut and that bottom cut across the top in these commercial buildings, across the top of the joist, the depth of the cut is extremely important. You don't want him cutting all the way through those joists, because that will weaken the integrity of that roof that he's standing on. So it's absolutely imperative that the cut guy is aware of the depth of his cut when we're cutting on these. These particular commercial buildings are a little bit smaller than our large tilt slabs, a little bit more obscure. They don't stick out as much. Just about every first due has at least one of these. And the reason they're of importance to us is because when we talk about the read on the roof, these can present some challenges as far as us reading the roof. The building themselves, multi-occupancy buildings, they have, usually there's some sort of office up front. The back part is either some sort of storage, light commercial, or industrial process in the back. So it's all over the place as far as what you have in them. And then you usually don't have any idea what you got until you pull up. So we're talking about the reading the roof. What you would think is that your structural members would be running the short distance in the building. And then we get in the underside here, and what you have your structural members, your purlins, running the long distance. So what they've done is they've, some of the interior walls they've taken and made them load-bearing walls. And then where there aren't any, then they've run a girder and then run some posts down to the ground. So the wall over here, you can see, has a girder up there. It's buried pretty good, but you can see it sticking out on this end over here. And then our purlins running 90 degrees to your girders. And then in between the purlins, we have joists. Your purlins are on 8-foot centers here, like we talked about. That's a rule of thumb you can use most of the time. Having on a wood deck commercial roof, having your purlins on 8-foot centers. And then your joists on 2-foot centers. In this particular building, our purlins are TJIs, truss joisted I-beams. You don't see TJIs in commercial construction too often. See it quite a bit in residential, not too much in commercial, but here it is. The thing about TJIs is they took and they engineered all the bulk out of the structural member. So you have a bare bone structural member. The strength is almost as strong as if it was metal or dimensional wood or a glue lam. But where we get into the difference is when it's being affected by fire. Fire will affect that way quicker than it would a steel member or a wood member, solid wood, or a glue lam type of wood. So in this building here, since it's not sprinklered, since there is no barrier between the contents and the structure, and a contents fire becomes a structure fire almost immediately. What that means for us is that we have a real small window of opportunity to come in here and have an effect on this fire. The fire, like I said, is going to be in the structure almost immediately, so it gives us just a real quick time frame to work on. And then on top of that, we have structural members that aren't going to be as strong while they're under the influence of the fire, so it narrows our window of opportunity even more.